All right, so what happens when we solve some more systems of equations? Let's see if we come up with any weird situations on this next one. So let's make a decision on which variable we want to get rid of. Quite honestly, let's just let's focus on the x's here. And so that means we're going to multiply the top equation by 3 and this one by 3 also. So that would give me 3x on the top, and the middle one negative 3x, and the bottom one positive 3x. So that's what I want to do here. 3x minus 3y plus 6z equals 30, and negative 3x plus 3y minus 6z equals 15. And then my last one is 3x minus 3y and plus 6z equals negative 2. Okay, so we are, I think, let me just double check. Negative 3, 5, 3, negative 6, 15, 3, 3, negative 3, 6, and 30. 3x minus 3y, 6c, and negative 2. Okay, oops. So we're ready to add these together. So we're going to pair them up, add these two together. So the x's are gone, the y's are gone, the z's are gone. So we get 0 equals 45. What is going on with this? Oh, those cancel all 2, and I get 0 equals 13. Well, guess what? That means we've got a no solution situation. Now, is it possible that 3 planes come together but not at the same place? That's true. What if the 3 planes formed a triangle? In other words, they did not all cross the same single location. So that's a no solution situation that you're coming across right here, because they don't cross at the same point. Let me see if I can find an example of that. Well, there's lots of situations where you could see planes that don't connect all together at the same location. And they don't have to be parallel. This is just, a couple of them can be parallel. This is obviously what we're looking for when they all come together in a single location. But sometimes like this, they formed into a triangle, right? And so you get that situation where they're not crossing at all. Or maybe they cross, but they all come together in a single line. That'll be eventually. This, however, is no solution, so they don't share. They don't all 3 have something in common. Here's another triangle situation. But just all kinds of situations where they don't come together in a single location. So just a couple things to look at. Well, what happens if you come across a system where there's a missing term? You can see on this bottom equation right here that there's no y, right? So missing y. Well, that actually means they've saved you a little bit of trouble. Kind of. But they're forcing me to use the first 2 equations to get rid of y. Okay? So that may or may not be as easy as you think, and in this case, I'm going to have to multiply the top equation by 2 because I'm trying to get this one to be negative 10, and I want this one to be positive 10, so I'm going to have to multiply this one by 5. So I'm going to get 2x minus 10y plus 2z equals 6 and 5x plus 10y minus 10z equals negative 60. So now I can add these two equations together. And if I do that, I get 7x, the y's disappear like I wanted them to, minus 8z, and on the other side, 6 minus 60 would be negative 54. Okay, so now you're saying, what do I do now? Well, that's where this equation comes in, because now I've got 2x plus 2z equals 6. And now I have to focus all my attention on these two equations. So the big goal I need you to understand is when there's a missing letter, that's forcing you to take the remaining two equations and solve for that and get rid of that variable. So they wanted me to get rid of that variable right there in those two equations so we could get to this situation right here. And now we're looking at it going, oh, let's see here. I think I need to multiply this one by 4 so that I can get these z's to be opposites. So the top one's going to stay the same, 7x minus 8z equals negative 54. And the bottom one's going to change. 8x plus 8z equals 24. And so now when I add these together, I get 15x equals negative 30. And now I can divide by 15, and we get x equals negative 2. X equals negative 2. Well, what am I going to do with it? Plug it back in? I'll use this equation. 2 times negative 2 plus 2z equals 6. So that's a negative 4, so I'm going to add 4 to both sides. 2z equals 10. Then I'm going to divide out the 2, and I get z equals 5. So far it's looking good. It looks like I got a negative 2 for the x value and a positive 5, so I know my first number and my last number, but I've got to find the y in the middle. Well, now I got to use those things and go back to the beginning. Don't use the last equation at the very beginning. You got to use something that has x's and y's in it, like this one right here. So I can do negative 2 minus 5y plus 5 equals 3. Now, obviously, that's negative 5y. If I add the negative 2 and the positive 5 together, since they're on the same side of the equation, I get 3. And then to get that to move to the other side, I'm going to subtract 3, giving me 0 equals negative 5y. Now, don't look at this and go, well, that's impossible. You can't do that. This must be no solution. That's not the situation we're in, folks. We can divide 0 by negative 5. It still gives us a number, and we still know that 0 is the y value, and this is our final answer. Remember, it's a location in the universe, and these three planes do come together in one place. But the key to that question is remembering or knowing what to solve for. Okay, we'll go to the next. Set up and solve a system of equations for the situation. In triangle ABC, the measure of angle A. Okay, well, let's see. It would be nice if they would give us a triangle, but they didn't, so now they're going to make me draw the picture. Okay. The measure of angle A is twice the sum of the measures of B and C. Okay, so if that means we'll call this one X, we'll call this one Y. Or maybe we should, you know what? Why don't we just do this? We'll call this one X, we'll call this one Y, we'll call this one Z. Let's see if that helps us. the measure of angle A, okay, we call that x, that's the equals, right? The is the equals, twice the sum, twice the sum of B plus C. Okay, all right. The measure of angle B, all right, that's my y, is 3 times the measure of angle C, which I called Z. What is the measure of each angle? Okay. What else do we know about the angles of a triangle? Because this has 2 equations and 3 variables, and that would be just like downright impossible to figure out. Unless we remember the 3 angles of a triangle add up to 180, which we learned about in geometry class. Ooh, time for some substitution. All right. So this is going to go in there. Wow, it's also going to go in there. So this would be the same thing as saying 2 times 3z plus 1z. That means that x is equal to, let's see, that's 4z times 2, 8z. Oh. Because now that can get replaced in there. So we have 8z plus 3z plus 1z equals 180. Okay, this is going to work. So 8 plus 3 plus 1 makes 12 z's. And so now we have z equal to, handy dandy calculator, 180 divided by 12, 15. So that's angle C. Now I'm going to use it to find, so we've got x, that's angle A for me. And we know that that's 8 times that, so we literally can do 8 times 15. 8 times 15, 120. And then y, which, that's my angle B. Well, that's 3 times 15, which is easy. That's 45. So those are my angles. Interesting question. I like that one. That's pretty cool. Okay, we'll go to the next slide. Anna, Bob, and Chris are in the 5th grade and do not know how much they weigh. Anna and Bob, so we'll just go with X, Y. So X, Y, and Z. I mean, if you want to do A, B, C, there's nothing wrong with that. So maybe we should do that. Maybe we should just do X, A, B, C. That way we're not A, B, C. Easy as 1, 2, 3. Anna and Bob together, Anna plus Bob, weigh 226 pounds. Bob plus Chris weigh 210 pounds. Anna plus Chris weigh 200 pounds. How much does each person weigh individually? Well, I bet we could do some substitution here. What if I take my first equation and I solve for B? B equals, and I move that C to the other side. So that'd be 210 minus C. And I do the same thing down here. So we're going to solve this one for A. We're going to solve this, or the middle one for B, and the last one for A. So that would be A equals 200 minus C, right? Because you're pushing that C to the other side. Now, what am I going to do with these? You can see I'm going to rewrite the first equation. I'm going to take that first equation and I'm going to do substitution in that first equation. So first I've got A, which is 200 minus C, plus B, which is 210 minus C, equals 226. And you're sitting there going, okay, well, how does that help me? Well, this equation is now, let's see, I've got like terms I can add. 200 and 210, so that's what, 410? I got the C's, that's minus 2C, equals 226. And so we're going to get rid of this to the other side by subtracting it. Negative 410, plus 226 equals negative 184, so negative 2C equals negative 184. And we just figured out the weight of Chris. Chris looks like about 92 pounds. Well, now I can use that and come back up here and I can find out what Anna and Bob weigh. So Bob is 210 minus 92. So Bob, 210 minus, not plus, minus 92. Bob weighs 118. And Anna is 200 minus 92. 108. Yep, 108. So we now know what all three of them weigh just by doing substitution. We took the bottom two equations, solved for one for A, one for B, and then we plugged those into the top equation. The key thing is you want one equation with one variable. One equation, one variable. That's the key, and once you can do that, then you just start solving. Okay. That's it for these notes.